4705. What are the main differences between the SDF and the localizer of an ILS? A. The usable off-course indications are limited to 35 degrees for the localizer and up to 90 degrees for the SDF. B. The SDF course may not be aligned with the runway, and the course may be wider. C. The course width for the localizer will always be 5 degrees, while the SDF course will be between 6 degrees and 12 degrees. The correct answer is B. The main differences between the SDF, Simplified Directional Facility, and the localizer of an ILS, Instrument Landing System, are alignment with the runway. The localizer is always aligned with the runway centerline, providing precise lateral guidance for instrument approaches. On the other hand, the SDF course may not be aligned with the runway, meaning it can be offset from the runway centerline. Course width. The course width for the localizer is fixed at 5 degrees. This means the usable signal for the localizer is within a 5 degrees angular extent from the centerline. In contrast, the SDF course can have a wider course width, which can be either 6 degrees or 12 degrees. The wider course width of the SDF allows for a larger area for aircraft to track and maintain course alignment. 4747. If the ILS outer marker is inoperative, you may substitute A. A compass locator or precision radar. B. VO or radials that identify the location. C. Distant measuring equipment, DME. The correct answer is A. Accuracy radar or compass locators found at the OM or MM may be substituted for marker guides, DME, as it were when indicated within the method, may be substituted for the OM. 4773. When tracking inbound on the localizer, which of the following is the proper procedure regarding drift corrections? A. Drift corrections should be accurately established before reaching the outer marker, and completion of the approach should be accomplished with heading corrections no greater than 2 degrees. B. Drift corrections should be made in 5 degrees increments after passing the outer marker. C. Drift corrections should be made in 10 degrees increments after passing the outer marker. The correct answer is A. Drift corrections should be accurately established before reaching the outer marker, which means adjusting the aircraft's heading to compensate for any crosswind or drift. Once established, the pilot should aim to maintain the localizer course by making heading corrections no greater than 2 degrees. This allows for precise tracking of the localizer and helps ensure the aircraft stays on the desired approach path. 4982. You have been given the following approach clearance. N696 US, you are cleared for the ILS runway 7 left approach, sidestep runway 7 right. At what point are you expected to commence the sidestep maneuver? A. At the published minimum altitude for a circling approach. B. As soon as possible after the runway or runway environment is in sight. C. At the localizer MD, a minimum, and when the runway is in sight. The correct answer is B. When you are given a clearance for a sidestep maneuver during an ILS approach, you are expected to commence the sidestep as soon as possible after the runway or runway environment is in sight. This means that once you have visual reference to the designated sidestep runway, you should promptly initiate the maneuver to align with and land on that runway. It is important to maintain proper situational awareness and make the transition safely and expeditiously while adhering to any altitude or obstacle clearance requirements. 4799. If Receiver Autonomous Integrity Monitoring, or AIM, is not available prior to beginning a GPS approach, the pilot should A. Use a navigation or approach system other than GPS for an approach. B. Continue to the MAP and hold until the satellites are recaptured. C. Continue the approach, expecting to recapture the satellites before reaching the FAF. The correct answer is A. If Receiver Autonomous Integrity Monitoring, or AIM, is not available prior to beginning a GPS approach, the pilot should use a navigation or approach system other than GPS for the approach. Our AIM is a function that ensures the integrity of the GPS signal by checking the accuracy and reliability of the satellite signals being received. Without our AIM availability, the pilot cannot be assured of the accuracy and integrity of the GPS navigation solution. Therefore, it is necessary to rely on another navigation system, such as VOR or ILS, that provides the required integrity for the approach.